So today's deep dive is, it's a bit meta.
A little bit, yeah.
We're looking at a source that is itself an audio guide. It's this technical blueprint for explaining the famous twin paradox, but specifically for an audience that can't see.
It's a really fascinating way to approach it. I mean, usually you see special relativity taught with all these, complex diagrams on a chalkboard.
Right.
But this source argues that if you strip away the visuals and just focus on the geometry and rhythm, you actually get a purer feel for the physics.
It forces you to build the model right in your head.
Right.
So the mission here is to explore why time isn't this universal constant we think it is. It actually bends with velocity.
And the source uses the classic setup for this, a trip to Proxima Centauri.
The ultimate road trip.
Exactly. It's about 4.24 light years away. So you have Twin A, the traveler, and Twin B, who stays home on Earth.
And Twin A isn't just cruising. They're going at 90% the speed of light, so 0.9 c.
Which is an insane amount of energy. But this is where the math and the blueprint gets wild.
Yeah, here's the kicker. When Twin A gets back, the calendars are completely out of sync. For the Earth twin, it's been about 9.42 years.
But for the traveler, their clock, their body, everything has only experienced 4.12 years.
They are now over 5 years younger than their own identical twin.
And it's not biology, it's just the physics. It's something called the Lorentz factor. At that speed, 0.9 c, the factor is about 2.3. That's your time exchange rate.
So for every 1 hour that passes on the ship, more than 2 hours pass on Earth. But let's get to the why. The source uses this great mental image, the like clock.
It's the perfect way to visualize it without, seeing it.
Okay, so walk us through it.
So imagine you're on the ship and you're holding a clock made of two mirrors, one on the floor, one on the ceiling. A single photon of light is bouncing between them.
Up and down, tick-tock. A very short, very direct path.
Right. But now, what does the twin on Earth see?
They see that clock whizzing by at 90% light speed.
So the photon can't just go straight up. By the time it reaches the top, that top mirror has moved. It has to travel a diagonal path to catch it.
It traces this zigzag, like a sawtooth wave.
And basic geometry tells you the diagonal of a triangle is always longer than the vertical side.
The photon has to travel a longer distance.
And here's the absolute rule of the universe. The speed of light cannot change. It can't speed up to cover that extra ground.
So it must take more time.
It has to take more time. The seconds literally have to stretch. That's time dilation.
But this brings us to the actual paradox part.
The symmetry problem. Yeah.
Right. If motion is relative, why can't the traveler say, I was sitting still and Earth was the one that zoomed away from me?
And if that was true, then the Earth twin should be younger.
So why isn't it a two-way street?
The source hits this hard. The symmetry is broken by the turnaround?
Acceleration.
Exactly. To get to Proxima Centauri and come back, the traveler has to slam on the brakes, turn the ship around, and then floor it again. They feel G-forces.
The Earth twin never feels that. That force is the proof. It shows who is actually changing their frame of reference.
That's the moment the reality snaps. The source describes how, during that turnaround, the traveler's definition of now, back on Earth, just sweeps forward across years of time. That's where the missing 5 years go.
And it sounds like abstract math until you realize we depend on this every single day.
With our phones, GPS.
Yeah, the source points this out so clearly. The GPS satellites are moving so fast that their clocks actually slow down by about 7 microseconds a day.
But they're also in weaker gravity, which, believe it or not, speeds their clocks up by 45 microseconds.
Giving you a net drift of 38 microseconds every single day.
If the engineers didn't constantly correct for relativity, your map app would be off by kilometers in less than a week. It would be useless.
And we've even seen it in people, the Kelly twins, the NASA astronaut.
Mark and Scott, yeah. Scott spent a year on the International Space Station.
Moving at 17,000 miles per hour. When he came back, he was technically, about 13 milliseconds younger than his twin brother.
It's tiny, but it's a real measured result. The math holds up.
It really validates the whole conclusion of the source. This isn't just a brain teaser.
No, it's a lesson in perspective. Our common sense is just a bias built from living slow lives in a strong gravity well. The universe plays by a totally different set of rules.
I love how the source connects that back to his own premise. Just as we have to reconcile two different clocks to find the truth, this audio guide asks us to reconcile different senses to understand reality.
Yeah, that was a really neat bow on it.
It really makes you wonder, what other constants in your own life are maybe just a matter of perspective? Where you happen to be standing? Thanks for listening to this deep dive.